Hi, so welcome to another video which is about the measures of data variability, and as the name suggests, we are interested in an extent to which data vary, to which observations are similar or dissimilar. To a great extent, it's also associated with the notion of predictability, as we're going to discuss a little bit later. So when it comes to the measures of variability, we are going to discuss three of them, which are range, variance, and standard deviation, and we shall start with the range. So in a set of quantitative data, range stands for the difference between the largest and the smallest measurement in a sample. So it's easy to calculate, it's easy to interpret, but in most cases it's practically useless. To a great extent because range might be biased by the presence of outliers, some untypical observations. So other observations might be more or less similar, they might vary to a very small extent, but because of the presence of some outliers, we might deal with the ridiculously high values of range. So let us consider our example. You can see that in our sample, the smallest value of income is 1500 and the largest level of income is 3700. So our range is equal to 2200. And as I mentioned before, we interpret the range as the difference between the maximum and the minimum value of observation in a sample. However, why it is misleading? You could notice that three people in the sample have pretty similar level of income. Like we have 1500, 1800, 2000, and there is only one person with a relatively high level of income, 3700. So this person is quite untypical. This person is an outlier. And the value of range is relatively high. So as you can see, three people have relatively similar income, relatively low extent of data variability, but nevertheless we end up with the ridiculously high value of range. So that's why, even though this indicator is easy to compute and easy to interpret, it's not that useful. That's why we are going to introduce a more sophisticated measure of data variability, which is sample variance. So we calculate sample variance as the sum of the square differences between the value of indicator associated with the particular observation and the mean value of indicator divided by n minus 1, where n stands for the number of observations in a sample. Sounds complicated, but actually it's relatively easy to compute variance in several simple steps. So this is an example. We are computing variance for the same sample as before using the same data. And as you remember, in the previous video, we calculated that mean value of income in a sample is 2250 units of some currency. So first, we will calculate the difference between mean value and observation value. So 2250 minus 1500 gives you 750. 2250 minus 1800 gives you 450. 2250 minus 2000 gives you 250. And 2250 minus 3700 gives you 1450. Negative 1450. However, there is one interesting thing to notice. We are not really interested whether the value of observation is bigger or smaller than the mean value in a sample. We are interested in the absolute value. That's why we have to calculate the square of every difference here. As a result, we get a positive number because whether you put positive or negative number to the power of 2, you will end up with the positive number. So this is the purpose. That's why we are doing this. So then we take each of those values to the power of 2. We have to find their sum. And finally, we have to divide the obtained sum by n minus 1, where n stands for the number of observations. So we are dealing with 4 observations. That's why n minus 1 will be equal to 3. That's why we divide the sum by 3, and voila, we calculated variance. Standard deviation is another measure, but it's relatively easy. It's calculated at the square root of variance. So that's why if we want to calculate standard deviation for the same sample, we have to take the value of variance and bring it to the power 0.5. Or in other words, we need to calculate the square root of variance. And this is what we've got. So standard deviation is more useful because it's like more compatible, to the value of our observation. And that's why in statistical analysis, we mostly use the value of standard deviation. But again, it's calculated based on the value of variance. That's why, there is no such a huge difference between those two. So another thing I would like to mention before we proceed is that in finance, and applied statistical analysis, variance is often interpreted as the measure of risk. So I know that risk is quite a complex phenomenon, like there are many definitions, many possible explanations, but when it comes to applied financial analysis, if you want to calculate the risk associated with investing in certain stock, you calculate the variance of return. So on this graph, you can see information about daily returns, like percentage difference in price, picked from 2 consequent days for Warsaw Stock Exchange, WIG, and Orange, which is, just some corporation here in Poland, like internet and mobile connection provider. So the first thing you can notice is that for Orange, there is a much bigger spread between the maximum and the minimum values. So you can already indicate that Orange returns will feature a higher degree of variation compared to daily returns of Warsaw Stock Exchange aggregated. And when we calculate the variance, you can actually see pretty well that this is true. So for Warsaw Stock Exchange aggregated, the value of variability, is smaller than for Orange. And this indicates that investing in Orange is more risky. It's a riskier option compared to investing in Warsaw Stock Exchange aggregate. I mean, compared to the situation when you buy some equal shares of all the stocks listed on Warsaw Stock Exchange. I know it's not a revelation, it's pretty consistent with the standard financial theory, but my point was that higher level of variance indicates higher degree of variability. There is higher degree of uncertainty. And consequently, we use variance as some applied measure for risk in finance. So yeah, this was the point. Okay, so thank you so much. I believe that's it when it comes to the measures of data variability. And in the next video, we are going to discuss how to compute simple summary statistics in Gretel. So thank you for your attention. Hope you enjoyed this video and see you in the next one.